Welcome back, everybody. I'm Ostrus. We are here today with some new features I just added to AI Toolkit. I literally just pushed this up and I'm building the Docker image to get all of that online right now. So ironically, this new feature is actually an old feature. In fact, it's actually the very first thing I built AI Toolkit to do, and that's these sliders. If you've been following my work for a while, which I doubt anyone's been following me that long, way back in the day during Stable Diffusion 1.5, I came up with a way to train these sliders. The basic idea is you can come to some of these and you can adjust the LoRa weight to change how, whatever effect you want. On this one, it's zoom in. The weights were really high. You had to go like -7 to 7 to get these to work, things like that. And I released quite a few of these way back in the day. So I did one for like skin tone, zoom, muscle size, hair length, the number of people, on and on and on. I just kept, making these. Depth of field, nighttime, curly hair. I built the script. That's what AI Toolkit came out. I had this idea to do these and I started doing them. It was originally based on this concept called erasing. And basically all you do with erasing is you kind of erase a concept from a model. And I was like, okay, if you can erase the concept, then we could enhance the concept. And even better than that, we could invert the LoRa and enhance the other way. So you end up with a LoRa that splits in both directions and you can run it forward, backward, whatever it is to make these sliders. So I've been doing this a long time and another paper has come out about this concept after that. In fact, I'm even mentioned in the paper because I discussed this with them at the time. So now I've added all of this to AI Toolkit. It's all built into the UI. I'm going to show you how it works. I'm going to show you how you can train these today. And the cool thing is this works on every model. You don't really have to build a data set. It's very simple to do. It trains extremely fast. You don't have to teach the model anything new. You're just shifting its knowledge from one concept to another and just making a sliding trajectory along your LoRa. So I'm going to be doing all this locally today. I have two GPUs locally. You can tell here I have the GPU 0. This is my 4090. And then I have GPU 1. This is a 5090. A couple cool things about this. We're going to be doing Quinn image today because that's my new favorite model. I absolutely love it. But this will work with anything. It should work with video models, image models, everything. I haven't tested it with video models, but should work. Should work with Stable Diffusion 1.5. SDXL, everything, pretty much any model that comes out, because the way this works is based on how the model itself works with its understanding of the text. Now I'm going to be training on this locally, but if you don't have a good enough GPU at home, or maybe you just want some extra compute, you can always pop over to RunPod. I have a video of how to use that, or really any cloud providing service, but I do maintain something at RunPod to keep that running. And if you haven't signed up for RunPod yet, use my affiliate link in the bottom. That just gives me a little extra compute to do some more experimenting on. So the big thing that we want to look at, normally we are up here in the top right. You see it? LoRa Trainer. This is a new toggle that exists. So when we click on this, now we have something called Concept Slider. When you click on that, your UI is going to change a little bit because how this works is a little different than your traditional training. So you'll notice that we have this new box here, the slider box. A few things have gone away. Differential output preservation goes away. And I've updated the prompt. So now you can do stuff like adjust a custom width. You can change the seed. You can do LoRa scale. This is needed for what we're going to do here. So let's get started. First things first, we have to choose a concept we want to do. Now we don't have to make a data set necessarily. I'll come over here to my data sets. I'm going to use Quinn person. I already prepared this. This is nothing special. I literally just went into Quinn and I typed photo of a person. Or I think I just typed person actually. But then I just generated 6 images of a person. You don't need a lot. You can use any data set you want pretty much. It's best to use images of your target. And it's also really good if you generate them from the model itself. So I'm going to be targeting people today. We're going to do 2 different ones. And so I just typed in photo of a person. I made sure that it kind of split evenly between men and women. You can tell with Quinn, it has a heavy Asian bias. It's a Chinese model. That's what you would expect. But that works because that's what the model currently understands. So that's going to be our data set today. For the first one, we're going to try to do something I call detail slider. And I've released one of these before for Stable Diffusion 1.5. Well, we're going to do one today, and we're going to do it for Quinn, and we're going to see how it goes. So let's get started. All the configs I'm going to do here are going to be specifically for 24 gigs of VRAM and under. In fact, we'll be way under that. You may be able to get by with less, and you can always adjust this as needed, but that is our target today. So I'm going to do GPU 0. That's my 4090. We're going to do detail slider. So we'll do Quinn, image, detail. Slider. Might as well put slider on it. Okay, we'll do Quinn. There it is. Quinn image. On the transformer, we need to do this 3-bit ARA. And we already selected concept slider over here. For our LoRa, we don't need 32 rank. We don't need 16 rank. Most of the ones I've done are 4. You don't need much. We're not teaching it new information. We're just shifting its knowledge. And because of that, you can have these very small. Helps them train faster. And it helps them, preserve their current knowledge because you're not dumping in a lot of new weights. So 4 works fine. Here's our slider class. We're going to come back to this though, because I want to go over this in a little more detail. Let's go ahead and set most of the other settings up. You see, we're going to save 250. No. This happens so fast. It is slower. It does multiple passes on a single step, but no. So, we can literally go bloop, 25. We're going to save every 25. We're going to sample every 25 because it's just so fast. Next thing we want to do, we don't need 3,000 steps. We'll do 300. Basically move all this down. This is 1E -4. We can bump that way up to 1E -3. So you count the decimal places. 1, 2, 3. 1E -3. Probably don't want to go much higher, but it'll handle this and it'll learn quickly with that. Because again, we're just shifting knowledge. We can be pretty aggressive. On the time step type, since we're doing detail, we don't want to change the composition much. I can leave this on weighted, but I'm actually going to move the bias to low noise. We're trying to increase detail in the images. We don't want to change the whole image. We just want to have it where, like, instead of a plain shirt, maybe they have a lot of buttons and fancy whatever's on their shirt. All that can be the same. We are going to unload the text encoder. So this says you have to have a trigger word. The trigger word doesn't even show up on the sliders. It caches everything. It's going to cache all of this up here. So we're just going to unload the text encoder. In fact, I may have this where it doesn't even show this. It just does it by default. For our data set, it's this one I showed you earlier. Very simple, just says person on it. So we'll just go to Quinn person. You can select, I have some of my other ones from my other videos here. You just need general data set. You can just, go download a bunch of images from Flickr or Pexels, whatever you want. It doesn't really matter. You just want to make sure whatever your target is, like if you're going to change a person or whatever it is, that most of your images have that in there. But your data set's not important other than that. Like, we're not finding high detail and low detail images here. We're using the model's current knowledge to expand those concepts. Come down here, sample 25. The rest of this, we can all leave the same. Everything's going to be fine. We'll get back to this. First, let's go revisit this slider portion and talk about how this works. So the way that this is going to train is it's going to actually do a lot of predictions with the model detached. So with our LoRa not active, right? It's going to come through and it's going to generate our target class. Our target class is whatever we want to affect. So we can do person, we can write style, we can write car, we can write t-shirts, whatever it is, whatever we want our slider to affect. That is our target class here. It's going to generate with the LoRa unattached, with the LoRa disabled, our target class, our positive prompt, our negative prompt, and our anchor class. And with that, we do some fancy things in the back end to make a new target to expand our LoRa. So we run it through one time with our LoRa in a positive value. To expand, we want to pump up this prompt. So we're amplifying that prompt. And then we want to subtract this prompt. That's with a positive value. And then we're going to flip the LoRa around and then we'll do the opposite. So we'll amplify this one and we'll subtract this one. And you can always go look through, see the code. It's pretty simple. I built it as a plugin. It's just a couple hundred lines and you can see how this actually functions. It's a little different if you read the Concept Slider paper that came out. It works differently than that. I do it differently than how they do it. Not a whole lot different, but I build the target slightly differently. So again, you aren't having to go build a data set. It's going to generate your data set kind of on the fly. It's generating your prediction on the fly to expand these concepts, because you're expanding what the model currently knows about these concepts. So for each one, we're going to take person, who is happy, and we're going to subtract what the model knows of just person. So you subtract person from who is happy, but it still understands the concept of person in the prompt. And so we just have left who is happy, and we amplify that to where if you just type person, all this baggage is going to come on it, and then all of this is going to be subtracted from it, and then vice versa the other way to make it a nice polar shift. Anchor class gets interesting. You can generally leave this blank. So think of this kind of like your target is kind of like your trigger word in a way. But it doesn't necessarily have to use this word to trigger it, because person, we can type man, and we don't use the trigger word person, but a man is a person. So it's kind of like it's the class of what the object is. And then so your anchor class, what this is going to do is going to make it where on the positive and negative predictions, it's going to try to match what the network already knows about your anchor. So for instance, if we wrote in here dog, because we don't want a dog to be happy and sad, so we can do this. And one of the main reasons that we have to do this is I've previously done one for skin tone. One of the issues you run into with that, so this is supposed to be light skin tone, and then we have dark skin tone. Okay, so it is right. She has light skin tone. She has dark skin tone. The problem is that it wasn't regularized, right? So we didn't have something to like hold on to. So the model's just doing dark, 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 dark. So not only does she have a dark skin tone, but it made the entire image very dark. And she has a light skin tone, but she also has a bright light on her. The anchor needs to be something that's kind of like this thing, or you could even do like empty room, whatever it is. It's just a prompt that it runs through without the LoRA active. And with the LoRA active, it tries to match it. So you wouldn't want to put man or woman here. Unless if you only wanted to target man, you could do man up here, man, and then do woman here to anchor where it's only going to affect men. So it's kind of complicated. Most of the time, you can leave this blank, because then it'll do what the model would predict without any triggering words, and then it'll try to anchor that. So that way it kind of works as a regularization. So it all depends on what you want to do. I mean, the great thing about these sliders is it's going to allow a lot of creativity, and it's going to make you have to be kind of clever with how you go about separating these concepts. Okay, because that's all we're doing. So for what we're doing detail. So we can just do the target class. We'll leave it blank. We don't need a target class. We're going to target everything. The problem is with anchor is we need something here. So we can just put just an empty room. Or we'll just do plain white background. We just need something to anchor. In our target class, we're going to leave this blank. So that's going to be just a blank prompt. Or we could even do like detail here. Detail. And so on the positive prompt, we want this to be high detail. Now on these, especially with the newer text encoders, like so back when everything was clip on SD 1.5 and even SDXL, you could do like everything was trigger words, right? So you wouldn't write like whole sentences such as make me an image of a woman that has, whatever. Instead, what you would do back in the day is you would put woman, black hair, comma, whatever, and you would generate your image that way. That was the best way to train or to generate images with a clip-based text encoder. With the newer ones, it is more geared up for sentences, and this is anything with T5, such as Flux, or even like with Quinn. Quinn is using the Quinn VL, so it's like an LLM. So everything it knows is text. It can get by with words. I mean, it knows what the words mean. But just keep that in mind that this is going to behave differently. So we do want to write a few things here. Another thing to keep in mind, even when we fix the anchor on the example I was showing you earlier, you still will get things like this. So here's later light skin, dark skin. So we're just doing a skin tone slider on this one is what we were doing. But you still have it with, it's really bright, and then this is in a dark room. So The positive prompt and the negative prompt don't necessarily have to be direct. So on that one, in order to fix it, where it actually start working properly, I put stuff like a woman in a bright room with bright lighting. So that way that both the positive and negatives are, you define the whole room of the scene so that the concept we're separating between the two would just be the skin tone of the woman. And it won't add all these additional hallucinations like the brightness of the room to our prompt. And some of this you won't know what it's going to be until you start generating them. And there's going to be additional hallucinations with what you typed. So you may have to expand your prompt. I'm sure we'll get into that today. This is a lot of talking. Let's come up with a good positive prompt. So we'll do something like high detail, intricate designs, fancy clothing, extreme detail. You can type all kinds of stuff here. If you want the clothing to be more fancy, you want their makeup to be more fancy, jewelry, whatever it is, patterns. You can type whatever you want here. On the negative prompt, we want this to be dull, simple, dull, plain design, low detail, flat design, etc. It's usually good to use your target class in your prompt. However, if what you're describing is in that target class, so we can be like, intricate designs, etc., that is a subgenre of detail. The LLM will be able to determine that apart generally. But I did use detail in both of these. So let's double check all of our settings. I can already see one I missed, and that is dataset size. I just told you about this. We can flip if we want, not that big of a deal. Because it's not really learning the images. One thing we have to do here is we do not need all of this. We're just expanding the concepts in the model, so we don't need to do it at 1024, 768. You can, if you want, you may get better results. But since we're just expanding and shifting the concepts the model already knows, we're not teaching it to generate smaller or bigger. We're just shifting its bias a little bit. 512 is enough for that. Let's head down to samples, and then I'll do a recap of all this again because I know I've been talking a lot. There's a lot of stuff to cover. Don't worry, we'll do a quick recap when we get done with this. For the samples, I don't need to do all of these. This is great for training a concept. I'm going to do 4, so we can get rid of everything but 4, okay? And we're going to do them all the same. So I want the same seed, and I want the same prompt. That way we can see how it's going to slide. So let's just pick one of these. Which one do we want to do? We're going to be increasing the detail. So I love the DJ horse prompt. If you're familiar with the default prompts, it's one of my favorite ones. I just love seeing a horse being a DJ with a martini. So we're going to copy this to all the prompts. So we don't need to change anything besides the seed. We could just turn off walk seed. That works. I just like to do this for good measure. I don't know. It's just, that's how I do it. Turn off walk seed if you want to keep them all the same. But this way we could have, if we wanted to generate more samples, we could do other ones with a different seed. So we lock the seed on the LoRA scale. So this is a slider, remember. So we're going to be doing from one extreme to the other. So we'll do -1. Generally I'd put 0.0 just to make it a float because I'm a programmer and that's how I think. -0.5. So this is going to be our low detail side. So generally -1 to 1 is going to be your scale. So if you want to remove detail, you run the LoRA at a -1 weight. If you want to increase detail, we run it at a 1 rate. And we'll do 0.5. So with this, we should be able to see the transition. If you want to, you can go bigger, but the LoRA can break down quite a bit. Actually, just to make this good measure, let's go ahead and do 4 so you guys can see the entire thing. All right, so the top half is going to be our getting less and less detail. The bottom half is going to be getting more and more detail. These extreme sides may not be coherent, and that's fine. But that way we can test the limits of LoRA. So let's go back to the top. Let's go over what all we changed because there was a lot of talking and a lot of me missing stuff. I'm going to do it on GPU 0. This is a 4090, so it's 24 gigabytes of VRAM. All these settings will work for that. I'm doing Quinn image. I'm going to do it low VRAM. I changed it to the 3-bit with accuracy recovery adapter. We changed the linear rank to 4. For our slider, we're going to do, our target is detail. We are doing high detail, intricate designs, fancy clothing, extreme detail, patterns. And then for our negative prompt, we're doing simple, dull, plain design, low detail, flat design. And for our anchor class, we're just doing a plain white background. We have changed the save every steps from 250 down to 25. We are going to only do 300 steps here. We changed our learning rate from 1E-4 to 1E-3. We changed it so that we're going to do low noise because we are working on detail on this one. We have to unload the text encoder. On our data set, we just selected Quinn person. We're going to flip it. We only selected 512. On our samples, we locked all the seeds at 42. We go from -2 for low detail at 1, low detail at 0.5, high detail at 0.5, high detail at 1.0, high detail at 2.0. I know you guys are probably tired of hearing me talk. I am tired of talking. We are clicking create job. And we're good. So you can tell NVIDIA GeForce RTX 4090. I hit play. All right, we have our first samples in. These are just the baseline. They're all the same. I mean, I go across, they're all the same. You can't even tell I'm doing anything. And that's because we locked the seed in and everything else is the same. The difference is the weight of the LoRA. But since all the weights of the LoRA are 0 valued, you're not going to see anything different here. We have the Quinn image detail slider training. We're on step 12. Remember, we're going to be doing it every 25 steps that we're going to be taking samples and saving. So you can look on here. It's taking about 10 seconds to run through a single step. And some of that's because, I mean, it has to do a lot of predictions. It's having to do without any gradients. It has to predict, what our positive, negative, anchor prompt, or target prompt all are. And then on actually doing a gradient prompt, it has to do negative and positive. And it's doing all that on Quinn on a 4090 in 11 seconds per one step, which is both the positive and negative LoRA being taught at once. So it's pretty fast for how much it's having to do. And it learns super fast. So keep that in mind when you see this. Come up here and look at the memory. It's 13.3 gigabytes of VRAM. Now, the thing is if you're actually training Quinn on 512 images, it's quite a bit bigger than this. And this is doing multiple passes. I honestly don't know why it's so low. I've checked it. It's working properly. Maybe I can optimize the other one better. I don't know. It's only 13 gigabytes of VRAM, though, to train Quinn image. I'm not going to complain. Don't fix it if it ain't broke. The first sample set is in. So we'll start right here in the middle. This is at half strength on the LoRA on. So this is low detail. This is half strength, high detail. Not a whole lot different. There may be a few little buttons. But as we go this to the low strength, it's not a total ton of detail being lost, but some. We go to the high strength. Okay, yeah, he's getting a fancier shirt on. There are a few more buttons. I mean, it's going to take a little bit for this to really go. We're at 25 steps. I mean, this is nothing. When you're generating an image, you do more than 25 steps. This is like just generating an image up to this point to get it to where we are. We've run a few steps. We're going to take a look. I've already kind of peeked at it, and we need to do some adjustments. So I'm going to go ahead and pause it. Come to samples. So you can see here. So it's starting to actually be kind of dull. I mean, it gets more intricate as we go over and more dull. But it's not doing it enough, and I want it to really amplify that. So I'm going to adjust this prompt. Let's go to edit up here. So remember, we have like high detail, intricate design, fancy clothing, extreme detail, patterns. We'll put busy, 4K. I think that's about it. I can't think of anything else. On the negative prompt, though, we'll do this one a little more. Flat, dull, plain design, low detail, flat design, simple, plain, bare, boring. Just to kind of amplify that a little bit. Other than that, I think we're fine here. I'll update that job. Actually, I do want to we have this on low noise. I'm just going to switch this to balance just so we get a little more aggressive with it. We'll update that job. We're only at 75 right now. I mean, we don't even stop till 250 normally. All right, our training is complete. I did go in and I added a few extra steps to it because I had to make a code change just to do some regularization on the model. But you don't have to worry about any of that. It's updated now. It's pushed up. So we did go to 400 steps on this. You can take a look here. This is our 400 step one. We'll start at the low detail. It doesn't get much lower detail than that. This is -2, so this is probably more extreme than the LoRA should go, but it gives you a nice smooth gradient. So you go from -2 to -1, -0.5 to 0.5 to 1.0, then it just explodes at +2. Even at 1.0, it's kind of a little chaotic. So, you know, the thing with the slider is we may not need to go that high. If we go up, you know, it stayed kind of chaotic. It even broke down at some points because we were pushing it hard. But this is great. We are definitely going from one concept to the other. One thing you can notice, and you see it on all of these as I scroll, it's a lot more high contrast over here and a lot less contrast over here. And some of that is just the hallucinations of our prompt. When you type in things like 4K, high detail, etc., it's going to have more contrast. So these are like tertiary hallucinations. And you can always go into your prompt as you're, training this and go adjust those. So you could actually type in high contrast on the low end side, maybe train it for a step or two to actually get the contrast to shift a little more over here. It's an iterative process. Like most of the ones that I released previously, I would stop every 25 steps and I would adjust the prompt to kind of balance everything out as it went. I'm going to edit this. I want to fix that contrast issue, and I'm going to show you how quickly you can do that. And this is the kind of iteration you're going to have to do on these to make them perfect. So we're just going to add another, it's done now. So if we just resumed it, it'd just be done. So we have to do 500 steps. We're just going to add another 100 steps, nothing too fancy. All we have to do is, since we have a lot of high contrast on this top one, it's darker. On this one, we can just write stuff like high contrast and dark. And so by doing this, we're just going to add a few extra triggers. So when it's separating the concepts, it'll move that bias a little more towards center. You just kind of have to trick the model a little bit. I'll update this job. We'll come to samples so you can see what I'm talking about. So see how it's low contrast here, and then over on the right side, it's really high contrast. With this new prompt, we should shift that a little more and make it a little more balanced. So I'm going to run that for a few more steps, and we'll see if that can balance out a little better. All right, so we got the next steps in. I'm going to go ahead and pause it because we're going to change it again, and I don't want to waste the compute. Stop it. So let's look. This is working. You can tell over here it is, it was kind of white, and now you actually have a defined image. This is on the -2. And so before it was kind of breaking up. This is a lot more defined, and it's darker because we wrote dark. And compared to this, I mean, it's definitely coming in a lot better that this is more high contrast. So we're balancing out, we're shifting it over, but it's still not great. And so here's another thing you may notice. Another tertiary thing it's learning is this is blue, this is more yellow. So you can't just type yellow in the prompt. So we're going to edit this, and I'm going to show you the best way to fix this in my experience. Here on the negative prompt, so it's more blue-ish, so we could write cool tones in the positive prompt. If you're trying to shift the balance, it's best to not do both. You just want to do one side or the other, and that'll cause the shift. I'm going to stick with this negative prompt because most people aren't going to want to lower detail. Most people are going to want to increase detail. So we can kind of be a little more, play around a little more with the negative prompt. So we had high contrast dark, and we're going to add sepia. So if you don't know what sepia is, it's basically kind of like this yellowishy tone filter. If you've ever messed with Photoshop or anything like that, sepia is just a Filter's been around a long time. It's that older, washed out, yellowy look. And so by doing that, we're going to shift the color a little more. We'll just do another 25 steps like that. Let's update the job, hit play. And what we're hoping to happen here is we're going to move some of this yellow tint over here and hopefully balance out that color. All right, so it shifted, you can tell. So it goes from the blue, we added that sepia, and now it's a little more shifted into the yellow space, but not too much. It's just enough where it's pretty balanced. So it goes from here, walking it up, to extreme detail, to breaking down at 2. So I think this is pretty good. I do want to run it a little longer, but I just want to show you guys that this is how you can adjust it. I mean, it's an iterative process to get it just right because you have to deal with all of the tertiary hallucinations that the model's doing. All right, cool. It seems to have kind of balanced out, so we're not getting any more yellow. It went from this to this. This is more simple, and this is at the 1. You know, at the 2, it explodes completely. So at 1, that's about where we want it. It's very simple. It gets more complex, and almost chaos. The horse turned into a man. Before it wasn't like that. But I do think that the colors are a little more balanced on this one. I think I'm going to choose this earlier one. It does feel like that adding the sepia to the negative prompt did the trick, and it's balanced. It's not overly correcting here. It's not continuing to go down that road. So I'm going to choose this one, step 450. I'm happy with that. You don't want to let it run too long because you only keep so many, but I'm going to download this 450 one. You can just click on here and download it. I'm going to upload this LoRA to Hugging Face. Check the description for the links. So that is how you can train your own text-based concept slider in AI Toolkit. I hope that's helpful. Let me know if you guys train anything with this. It's a fun little experiment. Let me know any tips and tricks you also find out with it, because it is one of those things you have to kind of tinker a little bit. And if you find some really neat ways to get around some of these hallucinations that the model comes up with, I'd love to know what they are. Be sure to like this video, subscribe to the channel. That helps me out a ton on YouTube. If you want to support my work even further, go check out ostrus.com/support. On here, you can see how you can become a Patreon, GitHub sponsor, or you can support directly with PayPal. And you can also check out all these amazing people and companies that currently sponsor my work. I would not be able to do this video or continue to develop AI Toolkit if it wasn't for these people. This is what I do full time. And if you want to help support that effort, come to this page, support this, check out all these amazing people. Your name can be on here next time. That's it for me, guys. I'm Ostrus, and I will see you next time.